Welcome to Beyond the Scan. I'm your host, Kyle Cooper. Joining me today is our principal, Jason Atkins, and one of our representatives, Bill Ray with Ray Engineering. Today, we'll be reviewing a tank installation project that used AsBuilt's laser scan and 3D model service, which helped the customer save time and money. So let's start by introducing our presenters. Jason, would you like to go first?
Hey, I'm Jason Atkins with AsBuilt 3D. And for those of you who don't know who we are, we provide 3D laser scanning and modeling services to both the power and manufacturing industries.
And I'm Bill Ray from Ray Engineering, manufacturer's rep up here in New England. We service mostly power, pulp and paper, a few chemical plants, and we're a 105-year-old family business, fourth generation. And we've been working with AsBuilt for probably about 9 or 10 months at this point. Today's meeting, we're going to be talking about a tank replacement project that we brought to AsBuilt. Being manufacturer's rep, we have multiple product lines. And we had a customer who was replacing 6 full start tanks down in concrete vaults at their plants. And we had sold them 6 48-inch diameter steel tanks. They're 500 gallons. They're there to replace a 250-gallon tank in these vaults. And as you can imagine, the size of the tank was going to be a bit larger, but they do not want to replace the vaults, as these would be a very expensive process. So we got the order for the tanks, and the customer then turned around and said, "Can you please come down and measure the vaults and all the piping and everything associated with it to make sure these things would fit for all 6 vaults at a couple of different plants?" And my first thought was, well, this was going to be very difficult to do and make sure this project happens correctly. But again, we had just started conversations with AsBuilt, and I thought this was actually going to be a perfect application for them. So we started the process by introducing it to the customer as an option instead of hand measuring, and also did a presentation for them. They thought that was a great idea. So from there, we gave them a proposal and started the process of scanning these vaults instead of hand measuring them. At this point, I'm going to hand this back over to Jason so that he can share some of the data that we brought up with these scans, and then we can look at how these scans really helped us execute this project excellent. So, Jason, back over to you.
All right, thank you, Bill. All right, so as with all of our retrofit projects we work on, typically the first thing we do is 3D laser scanning. And that's for a couple of reasons. The main reason being, typically we don't have accurate as-built drawings of the area of the plant. So I'm going to jump into a little bit of scan data here. So a couple things I want to point out is one here, this area below grade. This was the subject area that we were scanning for this project. But also notice the amount of data that was captured just from a few of the scans that were captured above grade before we went into the vault. There's a couple of advantages for scanning a project like this, one being a confined space and the fact that we don't want to have to make multiple entries into this space. We don't want to have to make multiple site visits. So by laser scanning this area, the first thing that we capture is the surrounding area here. And I wanted to share this with you. As we jump into this real view here, the great thing about scanning is not only do you get the point cloud for pulling dimensions, but you also capture a 360 photo of the environment. So this 360 photo captures everything from floor to ceiling. We have this black area here. That's the only area that's not captured, which is under the tripod. But in this 360 photo, we have the advantages of collaboration online with the customer, online with the engineering group, and we're able to really see, get a good idea of the environment that we're working in. We're able to move from scan to scan just by clicking the next sphere here. And the other thing that we're able to do inside the scan data is pull dimensions. So it's very simple to click 2 points in the scan data, and we're able to pull that dimension. Anything that would be very difficult to measure with a tape measure, you're able to do that easily inside the scan data. As we move down into the vault, it's as simple as just clicking into the next scan. Here we're also in the 360 view, but we can also look at this in the point cloud data as well. So every time we take a scan, we're capturing between 40 to 50 million scan points per scan. So the image that we're seeing on the screen is one of the tanks. We scanned all 6 of these, but we're able to move through this environment. Right now we're running, this is hosted in the cloud. So that's why we're seeing a little bit of a lag to populate the data. But the things we were interested in this project were our piping connections to this tank, the overall tank dimensions, the tank, not only the tank, but the vault. Then on the back side, we also had some level indicators that were on the back side. So we were in a very tight space between the wall and the edge of the tank. And then also the other thing we were considering is how do we get this tank in and out of this space. So once we were completed with the scanning and the processing of the data, the next thing we do is move into the AsBuilt model creation. So I've got this kind of section so we can see the same view. So when we're laser scanning, the laser scanner scans down to about 2 millimeters of accuracy. So we take that point cloud data and convert that into a 3D model of the existing space. Now, one of the things we did here was we also had, as Bill mentioned, we had 6 locations. So we modeled all of these 6 locations, and now I'll turn on a few of these so we can see what this looks like with all of the tanks overlaid. So the first question was, are they all the same? We found out quickly that the tanks were the same, but all of the vaults were different. And as a result, we also had some different layouts in the piping. We also had a few different arrangements here, not exact, on the back side of the tank for our level indication. The other thing was the stairs here. The stairs were not all in the same location as well. Once we completed the 3D model, the next thing we needed to know was, what was the arrangement of the new tank that was going to be installed. So if we jump into the drawings, these drawings were provided to us as a reference for the proposed tank that was going into this space. So we were able to take these drawings, and the first thing that we did after receiving these drawings was convert that into a 3D model of the tank. So now that we have the tank model based on the drawings, we go back to the original here. And so we wanted to lay that into the 3D model. So once we dropped the new tank in, we realized pretty quickly that, we tried a few different alignments, a few different arrangements. And so when we started aligning the connections, kind of the best fit, even with the best fit, we still ran into a few issues. Obviously, we would have to relocate some connections. But then also the overall height of the tank was an issue based upon the geometry of this piping here. The other issue we ran into was the limited access point here. We had a couple of the sets of the ladders that were okay. You still didn't have much room to walk as far as once you entered into the room. And the other thing we had was clash here. So we can see we had a couple of the vaults that obviously we don't have very good fit up. So from that point, what we started looking at was through an iterative process of changing the shape of the tank, changing the layout to figure out what would fit in this space. Also to maintain the volume that was required for the project, the capacity for the tank. And then through that process, we were able to lay out a new tank design. So this new tank design, we eliminated the clash with all of the ladders. We eliminated the clash with the wall. There were a few other things we had to take into consideration too. The overall height of the saddle had to be reduced so that we could lower the tank, and then moving these connections around. This layout really gave us a lot better access inside the space. And we were able to, from this, we were able to create the 2D fabrication drawings for the tank. Go into another thing we were doing was kind of looking at, this section view. Once we laid the tank in, we were able to confirm that all of our piping and all of our connections, in comparison with the AsBuilt modeling in the new design, everything was lined up. We had to make a few modifications as far as from the original tank design for the welded connections, the flange heights. But this was kind of the iterative process to get from the AsBuilt to the design model. And then from the design model, we were able to go in and recreate the fabrication drawings, so that these would be based on, one, the accurate AsBuilt environment, and two, through the process of laying the new design into that environment, we knew that this tank would fit into the space.
As you see in there, they had the intersection with the ladders. That'd be one problem that would probably be the easiest one to fix, but no matter what, it would cost you time, cost you money. Another thing that's hard to see on this one, but one of the vaults was actually shifted by 6 inches, and the very end of the tank was actually running into it. That would have been a whole new piping change on that one of the 6 vaults. And the overflows, we were not going to, this 48-inch tank was going to be too high. That problem really would have basically become a reduction in the volume of the tank that was usable. So you would have had maybe a 400-gallon use of the tank, even though it was a 500-gallon tank. Not knowing what the turbine manufacturer would have said about that, we don't know how much that costs to have fixed. So a lot of big price changes there that would have we figured out probably more maybe by some measurements, but the vault change size that would have caught us off guard. There was definitely a lot of infield change orders that would have been, or we did avoid by checking this out. And what we ended up doing was that 48-inch tank. Basically, we had a meeting with the tank manufacturer, the customer, and AsBuilt all together, collaborating on this. We determined that the 48-inch was too large in diameter and height. So we consulted with the tank manufacturer. They found out they get 42-inch heads. Within a day or so, we had that redesigned, had that 3D'd, showed it stretched out. We could fit it in there, shifted it over to make sure we avoided the wall, and that we made the overflow heights by lowering the saddles. And again, within a day or two, we went from, oh my God, we have a lot of problems here, to solution, let's start the fabrication. And there was a short timeline between when the customer had released us to build these and when we needed to get the first 2 tanks in for the first outage. So it really, really did help us avoid any real problems. And as the sales guy, they did the first 2 jobs, the first 2 tanks on the first unit, and I didn't hear anything. And as they started the second set, I decided to, usually no news is good news. I decided to be a little forward and call them up. And the customer basically told me, he says, yeah, there was zero problems. They knew they had to make some piping changes with the flange heights. That was all prepped and part of the project for the contractor. But besides that, they said the tank fit like a glove. That was their actual words. And they had no problems. And they went on to do the second two tanks on the next outage. And a month later, they two more tanks on the last outage. And again, they all fit like a glove. Exact same tank, all slightly different piping and vault conditions.
And
One
going
thing to
into the
consider.
project, or sorry, real quick, Jason, I was just going to say, the assumption or what you were going into the scenario with, Bill, was that all the vaults were exactly the same, and you just needed to get the same tank fabricated for all 6 volts. Is that right? That was the
That's what the customer has said. So, yep, there's 6 volts. They're all identical. And we just need, and the 250-gallon tanks are identical, which they turned out to be. The vaults weren't, but the tanks were. And they just wanted a tank, 6 of them, identical to fit right in that place. And, again, hand measuring, I know we would have missed a few of those items. We've all done that. We've all gone out and, something as tight and complicated as this, there would have been problems in the field. The 3D scanning avoided all of it. And the fact that, we didn't have to go back and remeasure when we changed it to a 48-inch diameter tank. We just dropped it back into this overlay, looked for where it intersected, went over what piping changes. Again, mostly just moving where the flanges locations were. And that way the customer then could present this right to the contractor, and the contractor knew exactly what he had to go with on this application. Yeah, you can see the overflows that Jason just put in. 2 of them came out the sidewall instead of out the back. 4 of them went out the back, 2 went out the sidewall. And as you can see, different heights, and that gap on the wall is that 6-inch difference.
So, Jason, on this type of a project, I mean, could you get away with just doing laser scan, or to really mitigate the risk that you're seeing on the screen here? Do you need the scan and model to be able to realize that cost savings to mitigate the risk?
Yeah, so there's a way to do this, with some overlays and scan data, but to realize the true value, converting this into 3D model space really gives that customer the visual experience and also the confidence that the equipment will fit within the space. And this is a relatively small project compared to what we usually work on. And a lot of times we're showing something way more complex. But the fact is, this project still had a budget. And even though the budget was much smaller than, a lot of the projects we work on, that means your margin for error and, to stay within the confines of that budget, there's not a lot of room for mistakes. So even though this is not a, multi-million-dollar project, this is still follows the same workflow, whether you're working on a complex project or very simple. And this just goes back to we don't do any type of retrofit projects without laser scanning, 3D modeling, and running clash detection, looking at the concepts and working through to the final design.
Bill, you said that you'd only been working with AsBuilt for a month or two before you brought us into this project. Was there any risk or concerns that that we might not be able to deliver, or uncertainty on our professionalism? I mean, what were your kind of thoughts bringing us in, and what was your level of comfort working with us so early on?
Well, it was my first project with you guys, but as a manufacturer's rep, I do a lot of due diligence on the companies I represented. So we had been talking for a few months before that, and I'd been through a couple presentations with you guys. So I was very confident that no matter what, this was 10 times better solution than me climbing down into that vault and measuring everything and finding all these different changes in the vault that were the same according to the customer. So I was pretty confident going in. And then when we did the presentation and we did the initial scans, it just proved me right away. It just was, this was definitely the way to go, and it was a lot simpler and a lot more reliable than me walking down there with a tape measure.
And since this project, I mean, what's the perception from the end customer on laser scans? Is it something they're asking for now, or is it something you add on to the projects and it's just yes, we know we need to do this. We've already realized the benefits of it.
Well, this customer here is really this really proved to them that laser scanning is very useful tool. We already have 2 or 3 other jobs with them that are not even as like this. They're totally different type of projects, but they're all laser scanning to show something, show a movement, show a fit, or function, that kind of thing. And this customer really has bought on and believes that this is definitely well worth it. Just keep passing that along to other customers, and as they go, they'll all. I think everybody's slowly learning that laser scanning is definitely an economical solution to these kind of problems, and avoiding problems like we would have had with this project.
How is laser scan and 3D model being perceived at Ray Engineering? I mean, through your organization and through the rest of your team members there, is it something that is considered across the board now in similar projects, or are you still, or do you look at it for specific use cases and scenarios?
I mean, I look at every project, in its own unique way. We have to solve a problem usually for a customer, but yeah, we have been applying laser scanning to assist other manufacturers we represent, help them reverse engineer products, help them confirm sizing before maybe an item ships out to a customer. We've definitely looked at it as a helpful tool, aiding us in our other principles, along with just general projects for AsBuilt to be doing as a standalone project. But a lot of them have seemed to have some relationship to another project that we're working on.
So my last question: if you were to put an ROI or cost savings, cost avoidance to this project, what kind of numbers are we talking about?
Um, Fractionally, I could say the cost of the AsBuilt scanning was a minimum of a quarter of what it would have cost to fix the problems that we ran into. And the overflow problem, that would have been, you're in an outage, you don't have much time to get this thing solved. You already have a 48-inch diameter tank. You would have had to install that thing, and you would have had to limit the size of that tank and the usage of that tank. How that would have affected the turbine manufacturer and the retrofit on that could have been exponentially large. It could have been a lot larger than the project itself. I mean, this is one of those potential problems that could hit limit of liability levels on contracts, and we avoided it. We completely avoided it by noticing that, by reducing the size of the tank, by reducing the saddle size, getting that all below that overflow, and making that the tank fully useful.
And I always say a lot of times laser scanning and modeling often becomes a free service when you consider this in the scope of the project. And yes, there's a line item for laser scanning and modeling in the project, but if we can just avoid one issue, typically that service is paid for. And then avoiding issue number 2, 3, 4, and 5, now you're really seeing that return on investment of using this 3D scanning modeling process for your projects.
I agree. Yeah, any one of the problems we ran into on this project would have cost at least the price of scanning.
Yep.
Great. Well, Jason, any last comments regarding this project?
I would say that, again, we don't approach any project without this being the first step. I think that if you have a capital retrofit project in any type of industrial facility, this should be the first step. And as I said, I think you'll definitely see the return on investment and benefit from this 3D workflow.
That's great. Bill, any last comments regarding this project?
Yeah, I can tell you, if any of my customers see this video, definitely reach out to us about this. And if not, we'll be talking to you about it, because any size project like this, where you're talking about replacement, movement, checking things out, even just the line moving something in and out of a location, we're going to suggest this 3D scanning. The accuracy is so good, and the ability to just jump on a Teams meeting, review all this, and get solutions taken care of in a short period of time, well worth it. Very, very well worth it.
Great. Well, gentlemen, thanks for your time. I appreciate the information and the project review. That's it for today.
Great. Thanks, guys.
Thanks, guys.
Thanks, everyone.